So today we're going to discuss a specific event or something that occurs within exponential functions, and that's doubling time and half-life. And the names really tell you kind of what it is that we're trying to find. So doubling time is the time required for exponentially increasing quantities to double. And so this can only go with growth. Half-life is the time required for an exponentially decreasing quantity to be reduced by a factor of 1/2. Or we're going to, if you had 10,000, you'd have like 5,000 left. So this can only go then with decay. And as you work through these problems, you want to just be careful. Are you talking about, our annually or our period type of exponential, this form? Or are we talking about continuous, which is this form? Okay, so let's look at our first example. Find the doubling time of a quantity that grows by 12% each week. So we're going to assume that that's our annual or our period. It's happening at a specific time. And the question is, well, we don't know the initial amount. What are we going to do here? Well, it really doesn't matter, and just stay with me with this on a second. Really, the equation we're going to solve is 2 times P naught equals P naught. And if it's 12% each week, let's say that's 1.12 to the T. You're saying, well, where did this come from? What we want to know is how long something's going to take to double. So let's just say, for example, the initial value was like 10. Well, then what we'd be solving is like, when does 20 equal 10 times 1.12 to the T, right? If 10 was the initial amount, 20 would be double that. And so hopefully what you're noticing, well, if you think about that, if you divided by 10, you would get 2. Right? Well, really, it wouldn't matter. If the initial value is 30, then doubling would be 60, and so on. So what I'm saying with this over here is that we want to do 2 times the initial value. And so no matter what that value is, we would start by dividing by it. And so that would cancel from each side. And no matter what the initial amount is, we're really solving 2 equals 1.12 to the T. And that looks very similar to the problems we did the previous week. So we're going to solve that with natural logarithms. Natural log of 2 equals natural log of 1.12 to the T. Natural log of 2 equals T times natural log of 1.12. We divide by that. And so we get T equals 6.12. And we want to keep in mind our input variable here. We're finding the doubling time in weeks. So this is 6.12 weeks. In other words, it would take this item 6.12 weeks to double its initial value. So let's look at half-life. Let's say we wanted to find the half-life of a quantity decreasing by 8% per year. Since it's per year, again, I'm going to assume that this is annual growth. So again, we're not giving any initial value, but think about, what do we want to happen? We want to finish with half of the initial value. So this equation is going to be 1/2 times the initial value equals the initial value times 1.08 T. And again, if you're not understanding that, let's think about the initial value as, let's say, 20. Then we would be looking at 20 times 1.08 to the T. And we want to know half of the initial value, so we'd be solving this equation. 10 equals 20 times 1.08 to the T. And here, if you divide by 20, what you're really solving is 1/2 equals 1.08 t. And so looking back over at our other problem, or our other equation we've set up, let's fix that. Okay. If we divide this p naught over, they cancel out, and so really we're solving 1/2 equals 1.08 to the t. We're going to solve that with the natural logarithm, so natural log of 1/2 equals natural log 1.08 t. Using our property, natural log of 1/2 equals t times natural log of 1.08. So t equals natural log of 1/2 over natural log of 1.08. T equals 8.31, and in this case our units, since it's per year, this is years. So in other words, in 8.31 years, whatever your starting amount is, you would finish with half that amount.